when we're looking at this, what I want you guys to see is I want you guys to kind of have that understanding that essentially we are comparing different shapes. To compare two different shapes and decide if they're similar, because this is the question. Essentially, my question is are these shapes similar? That's the question. How can I prove that? Well, the two ways that I can prove that is number one, if the angles are similar. If my angles are similar, then I can look at them as being similar. But before I do that, I also need to have the same scale factor. And we use a fancy word called corresponding sides. So I have to compare the same scale factor for corresponding sides. And all that means is that I have to be looking at sides that are similar to the shape. So in other words, in this case, we can see triangle or line AB would be the longest side of my rectangle, and in rectangle EFGH, EF corresponds to AB, their corresponding sides. So what I want to do is to decide if these guys are similar, I have to basically go through these two steps. I have to ask, are my angles similar? So I'm going to compare ABCD to EFGH. I'm going to compare those two triangles, and my goal is to decide whether, number one, are all the angles similar? And when I'm looking at these two triangles, the top one and the middle one, I'm simply saying they're all rectangles, they all have 90 degrees. To decide now, I have to check number one. Number two, I have to find the scale factor. So when I'm looking at finding scale factor, I have to compare the corresponding sides. So in this case, I'm going to compare the two long sides. Before I can actually compare them with scale factor, we know scale factor is a comparison between our image or our diagram and our original. In this circumstance, I need to decide which one's going to be my original, which one's going to be my image. And I'm just going to randomly decide that. I'm going to call this guy my original. I'm going to call this guy my image. And I decided that. If you went the other way, we could still verify it. The way I'm looking at it as an enlargement. If you switched them, they'd be looking at it as a reduction. All I'm going to do is I'm going to find my scale factor. And I know my scale factor is a comparison between my image and my original. So it's just a matter of putting my numbers down. My image in this case happens to be 7.5 or meters, 7.5 meters. And my original in this circumstance is 5.4 meters. So when I do my scale factor, when I compare these numbers, I'm simply going to take 7.5 and divide it by 5.4. Put it in my calculator. Divided by 5.4, I get 1.3 with the 8 repeating. Now, my goal is I should be able to see this same side length. So I'll do it in red here. I should be able to have the exact same scale factor for those two numbers if this is similar. So I'm going to compare them. I'm going to go through. I'm going to say, what's my scale factor for these guys? Same thing, image over original. So image was 2.5, my original 1.9. And when I take 2.5 and I divide it by 1.9, I get a number that's similar. It's close, but it's not quite perfect. Like it should be the exact same number. So I get a scale factor of 1.3157 and a few other numbers. You'll notice these are not the same. Because these are not the same, it's not similar. So what I did is I compared ABCD and EFGH. They are not similar. Those shapes aren't similar. So I decide, okay, well, that didn't work. So I'm now going to start again. So I'm going to erase everything I did, and I'm going to compare my other shapes. I'm going to compare ABCD to IJKM. So I'm looking at doing this again. I'm basically doing the same process, only now I'm going to compare two different ones. So same thing, I have to start by identifying which one's going to be my original and which one's going to be my image so I can compare those scale factors. My angles all match up, so my angles are good. My scale factor is going to be, and again, I'm going to highlight, this time I'm looking at 5.4 and 4.8 as my comparisons. Well, okay, image over original means I'm going 4.8 divided by 5.4. When I do that, I get a value of 4.8 divided by 5.4. I get a value of 0.8 repeating. Okay, so my hope is that I will get the same scale factor on this other one. So again, I'm looking at my side lengths, my shorter side this time, and I'm trying to find my scale factor, trying to match up my colors here. So again, scale factor is simply going to be image over original. In this case, my image is 1.6. My original is 1.9. And when I divide those, 1.6 divided by 1.9, I get 0.84. 2, and some other numbers. Again, not the same. So that means these guys aren't similar either. That's kind of an important idea. So now I've compared ABCD with both of these, and that tells me ABCD is not similar to either of these shapes because I didn't have the same scale factor. So again, I have to start from scratch. And now I know ABCD didn't work with any of them. So now what I'm going to do is I'm just going to try and look at this one, EFGH, and I'm going to compare it to IJMK. Same logic. I have to start by assigning my image and my original so I can compare my scale factors. So I'm basically comparing EFGH to IJKM, and I'm just deciding if they're similar. So same logic that I'm going to go through this one. I'm going to highlight my two sides, 7.5 and 4.8, and I'm going to put them to the scale factor test. Image over original, so in this case, 4.8 I assigned as my image, 7.5 is my original, and taking my calculator out, 4.8 divided by 7.5, I get 0.64. So let's compare the other one now. My scale factor. I'm comparing, just so I'm kind of keeping things consistent. I'm comparing, I'll do it in purple, 2.5 and 1.6. So looking at this, my scale factor for that relationship is going to be 1.6 divided by 2.5. 1.6 divided by 2.5. When I do that, I get 0.64. This is the same. So they are similar. And that was our purpose, was to prove which ones were similar. So now I know that EFG and IJH are similar. And it was a lot of work to determine that, but I was able to kind of go through that process to decide it. And it's comparing scale factor. Just so you know, and I'm not going to do it because it's going to take too long here, but I could do that exact same thing with similar triangles. The only difference is triangles can be flipped. So when I'm comparing this, I'm looking at it, and I mean, you can look at it a couple of ways. Triangles will usually have 3 different side lengths, right? So I can compare, and I could say which sides are similar. Well, I could say this is my shortest side in triangle TRS, and this is my shortest side in QPR. Same logic. Looking at it, 7.5 My middle number for that triangle, 5 is my middle number. Looking at it again, 9 and 6. So I can set up these similar, I can decide if these are similar triangles by simply comparing those scale factors and seeing if the ratio, we call it proportional, but the ratio between those sides is proportional. Do they have the same scale factor? I hope this helps you guys kind of determining. It's not about similar triangles being the same size. They have to have the same angle and they have to have proportional side lengths, which means same scale factor. Okay, thanks guys.